welcome to everybody this afternoon. A particular welcome to David Holdsworth, our speaker, and also to his two assistants, Delvin and Dick, who will be contributing later on. Great pleasure to welcome David. David's been a member of the Computer Conservation Society since its very early days, and I'm sure is well known to a great many of you. He's been interested for many years now in the preservation of software, and that's the subject of his talk to us this afternoon. And I think without further ado, I'll hand over to David to talk about the 3 R's of software preservation: rescue, retention, and relevance. David, over to you.
Yeah, well, the first technical problem seems to have been standing.
In that case, why don't you organise?
That's fine. That's
okay. Clip it on.
Yeah.
Why don't you organise that? I'm sorry, I should have just said Rachel sends her apologies. I think she's on holiday, and for anybody here who doesn't know me, I'm Roger Johnson. I am the secretary, as of the AGM. I'm the secretary of the CCS. So, David, over to you.
Now, you should all be able to hear that. Is that correct? Yeah. It's Brian Oakley really who got me into this lot. We were sitting next to each other at the posh black tie dinner, and Brian was chairman of this lot, and I said, Brian, you know, really, software needs preserving just as much as hardware, just as important. And he said, you're quite right, and coaxed me onto the committee, so that's so it's Brian's fault if you don't enjoy yourselves this afternoon. Now, I like to stress that what I'm talking about is a work in progress. Excuse me. The flipping hearing aid is grumbling. It's a work in progress. Things are always in a state of flux. So the talk you've got now is slightly different from the one I did in Manchester a couple of weeks ago, especially as I've got different people involved on the sidelines. The thing about, sorry, I should stress that all the stuff I'm going to demonstrate works on Windows and anything you can think of. This is actually a Linux computer, and it also works even on big endian machines. It's been tested on Spark. So one of the important things, I think, is preserving software in such a way that it works long term. But why should we want to preserve it? Well, it might at least be interesting in the future, and maybe even important. And in a museum context, we're used to preserving the original artifact, the glass case, the white gloves. When I walk down in the Science Museum, I see a big beam engine, and my childhood memories have that moving. Are they right? Yeah? They do have a little model which moves some of the time. I caught it out of the corner of my eye today. But it's software's raison d'etre is actually working at all. So preserving a working artifact, if it's an artifact we've got wear and tear and maintenance skills. With software, we don't have any of this maintenance effort, though I must say I put quite a bit of effort in at times. It's this issue of art via technology, I think. The sorts of things museums preserve are often things that were originally intended to be looked at. So preserving that function isn't that difficult. Whereas if it was originally intended to pump water out of the Thames, it's a bit more difficult. Well, software exists to make computers useful, but computers exist to make software useful. It's a symbiosis. But the software is at least as important as the hardware, because it's a honed artifact, often with many authors, and there's just too much skill gone into it to making the hardware. And its only physical manifestation, I think, is the orientation of the spins of the electrons in the magnetic molecules, and not even the electrons themselves. And the thing that's really bizarre, we can make perfect copies. Now you see, museums are very keen on the concept of the original. This is the original. Yeah. Well, there isn't really a concept of an original with software. By the time a piece of software has been developed, it's been copied around magtapes and discs and things. And frankly, there are several copies, backup copies and things, and they're all just as good and identical to the others. And I think it's maybe altered people's way of looking at it. But I reckon software is pretty important. Most people recognise those names there. And you might even recognise those people. That's software. What's really important in that room is the software in that machine, because that's Ritchie and Thompson. So, what do I mean by these 3 R's? Well, to rescue it, you've got to copy it from the surviving medium onto files to create something close to the original bits. And then you've got to keep it forever. And then, if you're going to make it relevant, you've got to provide access via today's technology. Because otherwise, there's a distinct shortage of KDF9s for running Egdon, and an even bigger shortage of atlases. So, we keep the digital images in the long-lived institution. I've talked about this sort of stuff before, and those are the kinds of institutions I have in mind. And I think we should have copies in several institutions, because the copies are not unique. But the trick is to keep the cost down so low that these guys will keep it. And I want them to keep it for free. Not because I'm stingy, but I am. Because I'm the auction after all. But because I think if the retention of that is in somebody's budget, somewhere down the line, some smart ass accountant will cross it out. Whereas if it's not, if they can't see it as an income stream, then they're less likely to give it the chop. If it's a very modest income stream, then I think it's at risk. Now, I was going to show you a lovely extract from Horizon on BBC 4 that allows you to ask the question, really, would it be possible for today's kids to understand what's going on? It shows an IBM 7090 running. But instead I've given you a picture of a Leo 3 and another Leo 3, because I couldn't get copyright clearance from the BBC. They didn't answer my emails once I started to ask a serious question. And copyright is an issue on preservation, because even now we've got an issue about the license with George 3. There actually is one for running it. So, we all remember that kind of thing. But how do I explain it to my granddaughter? And this sort of stuff. And that sort of stuff. Now I know it's a bit, but computing used to be like that. Brian might even recognise it. He's off at Elgin 2 terminal on the Leeds University KDF9 sometime around 1968-69, actually working on editing the time-sharing director, and that's KDF9 user code. But that in its day was important. See, you don't see pictures like that nowadays. You can help by labelling it. But now, computers look like that. In the future, well, I suppose I've got my mobile phone here, but that's another example. So, in the 60s, we had cards, paper tape, and all sorts of arcane control languages and things like that. What I'd like to be able to do is to provide the experience without the drudgery. Now, there was a lot of drudgery involved in computing in those days. So I think video will be useful, and the CCS is videoing things like the Pegasus in order to get that kind of preservation. But we need museum exhibits of the stuff, but the software is different. But we can remember, most of us here, data prep, job submission, and getting the printout. I'm trying to sing it's on the website. I think jokingly think of making a website we did an overnight turnaround, but but I thought maybe it wouldn't have many takers. But what I really like is a soft teletype, and I'm trying to interest somebody in writing it, where on the screen you see what looks like a real teletype, and as you type, it happens, and it makes a noise, so you need to be able to turn that off voluntarily in case you're in mixed company. But I think that would be quite an interesting thing to have. But whose experience are we trying to get? End users. Now, this is where I put my glasses on and the technology takes over slightly. Here is an attempt to do that for Western Algol. Probably, does that make things better? So that's the Western Algol program. And there's the program, and so that's the thing that people prepared on the teletype and such like, with a slightly different character set for use of modern character sets, and the instructions on how to do that are down the bottom where it says type in Algol in the 21st century. And then you can, if you can find your cursor, there it is. I'm afraid I've got different images on the two screens. I couldn't make the two mirror each other. But you can run this program. Oh no, that's no, it's not a serious issue. You see, what it is, there's a race between two processors. I'm afraid when you're running it all on the same machine, the wrong one wins. It needs improving. I did say it was work in progress. But here we see now what it would have looked like back in 1968 or even 65. There's the Algol program as it would have looked, and up there you can get, and that's what you actually get, you know, and that was what that's your printer output. So that's what I'm trying to achieve as a way of providing an end user experience from 1960s type computing. Now, of course, you might decide that that's really not a very interesting program, and so you want to go back, but so you can edit it. Here you see, and sort of put in something like dv equals, and you can actually read data in, and then you can try and run that. And you see, the right one's won the race this time. It's actually been updated. So let's see what get it now said. Now, nowadays all compilers produce the same kind of error report because they're all implemented with GAC. Whereas this is an operator precedence grammar, and so you can see it differently. And why is it? Well, it says it's fail number 9. So you get the manual out and find out what fail number 9 was. But we're slightly more fortunate than that because we've got our manual here. And fail number 9 is a legal statement, the limit misused, and that's because there's no colon in front of the equals. When you go back there, it's written in Java or C. Oh, the bracket machine as well. But enough of that. There's a way of just indicating that's an attempt to produce the end user experience, and frankly it's the best shot at the moment as a technique of showing what it was like to create the job submitted in those distant days. But what about computer operators? We're all computer operators now. But you sometimes see videos of operators at work, because you were going to see one if the BBC had said you could have this. It's a clip out of the programme about Voyager probes. But we can do emulation of the operator's experience. And we've got a load of instructions on how to do it on the website. There you are. Now, what I'm going to do is unload the printer. So, what I'm doing. So now, if we go back, let's just move that over a bit to the right, because we've got some printer output here. when we say a printout, it says can't find it, that's because of course we just deleted it. So change the directory appropriately, and then now many of you will have seen that before. That's George 3. Not a simulation of George 3. That's the real George 3 really running on this laptop. And now, if we go back and look at the printer output, there we are. Those of you who use 1900s will recognise that kind of thing. Now we've got this question of how we sort of simulate other things, because now you want to read some cards. Now we've got an arrangement whereby we can tell the operators to engage device number 4, and it has to read some cards and do some more jobs. And then if we look at the printer output again, we see we've got some more. And there's even an Angle 68 program in there, and there's some answers from it. You can see that computing in 1920s, well, this is, I'm not quite sure what date this will be, but it's not just like it is now. But of course, George, you sometimes wanted to get rid of it so we can say it's all gone wrong, we'll have a post-mortem, and we'll send a post-mortem to the line printer. And of course you've got to wait for the line printer to do all the printing, which might take several hours. Fortunately, our line printer is very fast. But there you are. Those of you who've never seen that is the George 3 post-mortem. In all its gory detail. So, what we're trying to do here, hang on, let's go back. I'll just drop out of that to my crib sheet and back here. And then there are engineers, they have software, but I'm afraid we've not done much with engineering software. For one thing, it tends to test all sorts of hardware properties that will be very difficult to emulate. So, maybe nothing much will happen in that direction. Now, if you want to rescue stuff, I think you've got to capture it onto media neutral form. By that I mean, you want it to be in files that can be retained indefinitely. So, the surviving material, usually, well, some of it's machine readable, but usually by a machine that doesn't exist anymore, or at least exists in only a very few places. Half-inch magnetic tape often can still read. Awkward magnetic tape meant things like Leos with a funny number of tracks, and KDF9s as well. Paper tape, cards, we can usually deal with those. In fact, I've made a paper tape reader. When you use a scanner for reading paper tape, it's a bit slow, but it works. Printout often survive, but the snag is printout is not very machine readable, especially some you'll see here. So I think what we're indulging in here is standard software archaeology, trying to create digital copies of surviving material, get it working, make sure we got some documentation, and make some more. And it's all done by web pages and searchable. The software we want to be executable and have a web interface. So, we're trying to rescue the software from obsolete media and rescue the genuine documentation, make it all machine readable, and provide an environment for running stuff. The story so far, well, the first thing I got involved with was George 3. On the ICL 1900, I decided it would be possible to write an emulator which would have the effect of running the real George 3. And so I started to do this, and I actually put some stuff on the web about doing it. And a young guy who used to be at Manchester Grammar School picked it up and improved it a lot, and he's over there, and he'll tell you about it in a few minutes. So then It was actually rescued from a 2800 DME installation. And a guy called Brian Spoor, who unfortunately is not here today, but often comes to these meetings, and Brian used it for rescuing the census data from Malawi, would you believe. And then Brian Richmond, who is here, came across some printerless things, and we actually got Western Albo to work with a team, including Brian and Bill Finder. That's all in Resurrection. And then Atlas Autocode for KDF9 turned up, but that's gone on the back burner for quite good reasons. Atlas Autocode sort of became the father of INC, the Edinburgh programming language, and I'm now beginning to suspect it's actually something to do with the compiler. On KDF9 in Leeds, we implemented a system called Elden2, which was very carefully printed out by the people who ran the machine down and given to the library, who deny all knowledge of it. So anybody who says, oh, the way to preserve stuff, print it on paper. Paper, it's not a way to preserve it because it's so expensive to find a place to keep the paper for decades that eventually it'll be on somebody's budget line and it'll get crossed out. And they'll just lose it. And now I'm working on the EO3 intercode and various other intercode programs which turned up, and because I've never worked on Leo, I thought this would be a good way to find out what it would be like in the future for people investigating machines they never knew. Now, colleagues, my idea is at this point that Delwyn will come and say a few words. And the theory is that these pictures will appear. So, Delwyn, can you stand up, introduce yourself? By the time you finish telling things, it's like this. Take that. You never thought of that aspect. Sorry.
Okay, hopefully you can hear me.
Yeah.
Good. Right. So while David gets the technology ready. So yeah, my name's Selwyn Holroyd. I'm co-author of the George III Executive Emulator, and also I'm leader of the 2966 Restoration Project at TMOC, amongst other things. But that's the most relevant for that. So what I want to talk to you about is how we've made use of the Executive Emulator in the museum context. And I think what I'm going to talk about here is actually a really good practical example of how you can use emulation within the museum context and use it to help bring old hardware back to life again. And also, of course, it illustrates why preserving software is so important, and you'll see why as I go through what I'm about to say. So, how did I get involved with George and with the emulator? Well, what you can see on the screen there is unfortunately rather a dark shot of an ICL 1902T installation that existed at Manchester Grammar School, which is where I went to school. And that was between about 1979 and 1986 that system existed. Originally it ran Maximop, and then later on it ran George III. And this was really, well, that's not working here. Oh, no, it's just this one. So that's a slightly brighter view of the system there. It was really my first computer, if you like, because this was in 1981. I think we had a ZX81 at home, but obviously a mainframe was a lot more exciting than that. You could do a lot more with it. And we were given quite free rein as schoolboys to actually operate the system, and consequently I learned a great deal about George and about how mainframes worked at quite a tender age, if you like. Now, when the system was decommissioned in around about 1986, for some reason, and I can't now tell you what made me decide to do this, but I decided it would be a really good idea to keep a copy of the file store. Now, when I say a copy, this was a stack this high of half-inch magtapes, and for many years those tapes lived in a cupboard at my mother's house, and she went on at me a great deal for what the heck they were doing there, and they were thrown away. So And at the time that I did this, I really had no idea what I was going to do with these tapes. I didn't really have any clue or inkling about emulation, and indeed at the time it wouldn't really be feasible to think about doing emulation on any other hardware. So, I saved them. I'm not sure why, but later on this did become quite useful. And it was only in the 90s, much later on, late 90s, that I began thinking, these magtapes are probably going to rot if I don't do something with them soon. And I began looking around for somebody who might be able to help me read them. And at the time, I wasn't thinking of emulating George. I didn't really have very much documentation, and I thought that would be too difficult. But I did think maybe I could write a simple emulator to bring some of the old programs that I wrote back to life. That was really the scale of my ambition for it. And it was in the course of looking around for somebody who could do this and finding a lot of very expensive services that would do it for more money than I had for what was effectively a personal project. I came across David's website, which was part of the CCS website, and of course his mention of George, and he had some printouts on that website showing George beginning to load and then crashing, thinking there's some problem, which I won't go into. But so I very quickly made contact with David and offered my services, one thing to the project, and also my file store. I'm happy to say he was pleased to accept both of those things. And so between us, we very quickly had a fully functional emulator that could run not only George, but also all the subject programs as well. Because we'd emulated the George executive, it's actually the executive that does all the time sharing and handling user-made programs. So actually getting a fully functional system was a bit more than just making George run under the emulator. And indeed now it supports pretty much everything, including quite advanced things like multi-member programs, if you're familiar with 1900. Now, one of the really things about the design of the emulator, I suppose, that seems proven to be very useful, is that it wasn't designed to emulate very closely any particular machine in the 1900 range. So it was kind of a generic 1900, if you like. And that's we'll see a bit later how that has become useful. And the other thing is that the components were implemented as separate processes. So the main processor would run as one component, and then things like comms controllers would run as separate processes. And again, that's made it quite easy to extend for other purposes, which I'll go on to in a minute. So that's really the start of the story and how I became involved. And then sometime later, we were discussing this before the talk, and we're no longer sure exactly when, but sometime between 2001 and 2005, we were contacted by a gentleman called Alexei Gordienko, who is a systems programmer, or was, based in St. Petersburg in Russia. And to our complete amazement, he told us that they were still running George 3 on a 2966 for real job. This is actually running the payroll in the factory. And we were absolutely amazed. David and I were amazed, and indeed ICL were amazed, because everyone had thought that the last running George 3 system was actually at British Steel, and it closed down in 1999. And in fact, David was able to obtain
that's right,
files
from original.
Exactly, a lot of materials, a file store and so on from that installation. Nobody had any clue that there was still a 2966 running away there. So Alexei began using our emulator really as a means to help with his work as a systems programmer. So it was much easier for him to run his systems programming jobs on an emulator rather than having to reload his main system and so on and so forth. But he was incredibly useful in that he set about copying pretty much all the tapes and documentation that they had for us, and he copied them into the 1900 George emulator format. So as David was saying, files, essentially, which can now live forever. Some of the things that he copied included a complete CME installation environment, and also the CME George 3 Executive, which at the time we didn't really have any use for, but we thought, oh, thank you very much, that's useful, we'll put those with all the other things. And of course he copied a huge amount of documentation, most of which is now available on Brian Spore's website, which is icl1900.co.uk. And you can download any of that if you feel the need. Now unfortunately the machine itself was mothballed in 2010, And because we've now lost contact with Alexei, we're not sure what the current status is, but I think unfortunately it's probably safe to assume that it has since been scrapped. However, while it was in existence, he did a great service to us by preserving all of his software. And that, by the way, that is part of his installation there. So the next step, now moving on to TNMOC itself. So I started volunteering there in 2009, and I did that specifically to work on the restoration of the 2966. Now, when I started on that, I very quickly realised that this would be a major job, and it would probably take many years before we had any system that would be capable of running anything real. But meantime, we had this emulator, and I wanted to be able to run George in a museum context, but I wanted to be able to do it in a sort of realistic way. So I started looking out for a suitable ICL terminal that might support running George and that the emulator could drive. And eventually, of course, I had an eye that a terminal could be used to connect directly to the 2966 when we got it working. So I discovered sometime later that Jim Austin, so Jim has a very large private computer collection based in Yorkshire, and he has all kinds of things. And I discovered that one of the things that he had was an ICL 7501 terminal. Now 7501 is effectively, it's a dumb video with a comms controller built into it. And because of that, it means it needs firmware loading to do anything. Otherwise, you switch it on, you get a blank screen, and that's it. But luckily, at NGS, Manchester Grammar, we had similar equipment. We had 7502s, and we had the terminal executives, the firmware that would drive this thing. Now, if we hadn't had that, it's very hard to see where we would have got it from, because you're not going to find it by Googling, that's for sure. So I was able to arrange a loan of the terminal to TNMOC, and Jim agreed that it would be fine if we restored it and used it for general operation. And so we did that, and I built a USB to a synchronous serial interface, which is necessary to allow the terminal to be connected to a normal PC. And then I adapted the George emulator to allow it to talk to this hardware. And I did that just by adding an additional module which sits between where if you were running the emulator at home, you would put a telnet session in. And this effectively is a telnet to hardware interface that then talks to the real terminal. And the final step then was to bring George itself onto a Raspberry Pi and package the whole thing into a box. And the whole thing now lives hidden in the back of an EDS-200 that happens to be, disk drive that is, that happens to be conveniently close by. And there you can see the terminal, probably I think on the first day that we actually got it to come up with a George login prompt. And that terminal now runs regularly in the museum. To be honest, it doesn't normally show visitors George directly. It normally runs Colossal Cave Adventure, which we happen to have, again in the MGS file store, which is, as probably most of you are aware, is one of the first adventure games. And of course visitors love playing on it, and most of the visitors don't know or care that it's George underneath. But if we do get interested visitors, of course we can quickly break in and we can show them anything about George that they want to see. And it is an authentic experience because it's running at least partly on the original hardware. And if you think about it, for most users, they never saw the mainframe that George was running on anyway. All they ever saw was the terminal equipment. So for most users, it's pretty much as good as having the original hardware. So the last thing that I'm going to talk to you about is the 2966 itself. So that's a view of the whole installation there at TNMOC. Now, very early on, my goal was to be able to run George under CME on this machine. And I quickly realised when I started the restoration that the disks would never be reliable enough to allow for their regular operation. So exchangeable disk drives in this kind of environment where you have lots of visitors running around, you've got carpet, dust, wild temperature variations between day and night. None of that is conducive to reliable operation of exchangeable disks of that vintage. And of course we have a finite number of disk packs, and if you get a disk crash, then that's it. That's the drive. Possibly repairable, but the disk pack definitely not. So I was fairly sure that we had everything that we would need to establish George on 2966. So we had the CME installation tapes and firmware and documentation that came from the Lexi in St. Petersburg. We had our file store from NGS, and we had the George system software itself that came from a variety of places, obviously from the emulator project. A lot of those tapes originally came from either British Steel or from ICL itself. But it was a bit of a chicken and egg situation in that you need a working CME system in order to install CME. So I guess no one thought of the possibility of someone being crazy enough to try and install CME on the last remaining 2900 system. So because I'd realised that we would need to emulate the disks to allow for reliable operation, and because that was going to be quite a big effort, I realised, I wanted to at least attempt to see if I could build a system disk image that I thought would work before I went to all the effort of actually doing this job. So earlier this year I adapted the George 3 emulator to convince George that instead of running on a generic 1900, it was running on a generic 2900 environment. And in fact, it was quite happy with that, and it only required changing one bit in the executive replies to convince it of that. And also I supported the various 2900 disk types, including EDS80s, which is what we were trying to create here as an image. And George, the emulator, supported all of the necessary installation tasks that we needed to do, except for one, the last stage, which is running a program called Kipple. Now, Kipple is an exec mode utility, so that means it doesn't run under George, it runs on a very low level microcode interface. And unfortunately, that's one of the few things we don't have any documentation for. So I decided it was probably too difficult to try and emulate an environment that we could run Kipple on in order to allow it to do its job. And what Kipple does is it copies the, if you like, the system control file, which is the elements you need to boot the system, from the bit of the disk that the 1900 environment can normally see onto the bits that are normally hidden. So you have outer cylinders which are hidden from the 1900 environment, and these are what the machine actually boots from. So that bit's quite critical. If you get that wrong, then nothing will happen when you try and boot. Eventually, though, I managed to track down enough documentation with the help of the Bracknell archive at ICL to allow me to discover the format of the system control file in enough detail that I was reasonably sure I could functionally simulate what Kipple was doing and create, finish off the process of creating this bootable image. So then I went ahead and built the emulator, and I'm happy to report, very happy to report, some breaking news. As of last weekend, we actually managed to load George 3 onto the 2966 for the first time. And so once again, we have an operating George 3 installation on real hardware. And the only difference that we've noticed so far is that the adventure game runs a little bit slower than it does when it's running off the pan. Which is, I suppose, inevitable. So, I think that the lesson from this is that all of these elements have come together, and at the time that we preserved some of these software components, we had no idea what use we were going to put it. But because it was preserved, it has enabled these things in the future that we had no inkling of at the time. And it's now gone full circle, and we've gone from 2966 to emulation back to real 2966. So, so for the future, the emulator now that we have an operating system, the emulator will continue to provide some support to our operations, so we'll be able to use it for offline testing, data preparation, and so on. Of course, any issues that we might encounter with George 3 itself, we can investigate a lot more easily on the emulator than on real hardware. And of course, it will continue to provide a means to run the terminal when the 2966, for whatever reason, is not running. And we don't anticipate running that every day, whereas the terminal is a lot more lightweight and can be. So hopefully that's given you a flavour of what we're doing, and I'll hand you back to David. Thank you very much for your attention.
So does the 2966 running entirely off emulated disks?
Yes, that's right, yeah. So emulated EDS80s, although the emulator itself will, when the software is finished, will allow for emulating any of the 2900 disk types, SMD disk types.
So you needed an interface between the emulated discs and the 29.
Yeah, the disco emulator. Well, I can take. Do you want me to take questions now? Or?
No, let's do it, because otherwise
Yeah,
we're deflected into a very hardware-oriented direction.
Well, I'm quite happy to answer the questions at the end.
Yeah.
Okay.
Yeah.
Give you the mic.
So, back to colleagues. Now, the BBC Doomsday. Oh, sorry. Yeah. The BBC Doomsday. That's coming through, is it? Okay. Yep. And now there we have. Do you remember the Doomsday Project and how it had these 12-inch discs that were going to last forever because they were indestructible? The only snag was the Philips laser vision reader that read them was not indestructible. But that's one of them. Now, keep moving your data to modern hardware. So, press the right button. We've got no faith in long-lived media. It's not the way to keep stuff. Now, the Brooke and Morris compiler seems to be about the only thing of Atlas that survived, but it has been, without doubt, a very seminal piece of computing. And Dick and Bill Purvis are working on bringing back to life that emulator. And the theory is that when that says that, we shall see. Come on, come on, come on. There we are.
Don't you just go on for an overhead?
No, it was me that was not quite pressing the right button. This is Dick Leatherdale, who, well, basically he'll tell you what he's been doing, but he's been working on the compiler. Sorry, hit the space bar to change the image. Yes, it's Glady's style, unfortunately. I couldn't just stick around. Just hit the space bar and change it.
Okay, so there are three of us today. This is a lecture that's entitled 3 R's, and 3 is a number which you're going to hear quite a lot of. The Atlas, Ferranti Atlas machine was a very, very physically large machine, probably at least the size of this room. I have one in my PC at home. It's an emulator. It seeks to be able to run Atlas programs. It doesn't run many at a time, just the one. And it has 3 elements. There is an emulation of the store. There is a compiler for the assembly language that is built into the emulator. It's not an Atlas program. And there is an execution engine. That's all I'm going to say about the emulator. What we have, however, is three pieces of software which have been rescued, all of them from paper. And the first one is an interesting one. It's basically the very base of the operating system. It's in something called the fixed store. Now, on the real Atlas, to change the fixed store bit at a time, you would need a pair of pliers. We don't have a pair of pliers that works with my PC at home, so what we do is we emulate the fixed store and we compile into it. Now, I was fortunate in being able to find a copy of the fixed store in the National Museum of History of Computing, which at that time was resident at John Rylands Library at Manchester University. And what I actually found is something like this. It's a line printing system. It's not actually the program that was compiled to make the fixed store. It's a decompilation. Somebody, goodness knows who, has written a program which interprets what was in the fixed store and prints it out as if it was in something roughly like the assembly language. Most of the bits that I've been interested in are to do with extra codes, little subroutines inside the machine, inside the operating system, which are callable as if they were instructions in the normal set. So we start with that. That is the little subroutine for 1604 and 1605 extra code. You'll notice that I've written on this piece of paper because I've got a photocopy. I don't have the original. And there's no various marks that I've made on it to try and help me interpret it. And what I actually interpreted is that. That is a proper piece of assembly language, reasonably understandable, and you'll see that that's how it's come out. And that was reasonably straightforward for a number of reasons. Firstly, you've got a reasonably good printout to start off with. And secondly, all these little routines are relatively small in themselves and are testable in isolation. They vary between 2 instructions for the shortest one and something like 20 instructions for the largest one. So they are possible to actually extract these from the listing that I've got, one at a time, test them, and then move on to the next. So that's not too difficult. Now the second thing I got from the John Rylands library, there are three strands to this, was a listing of the runtime library for the assembler program, Atlas Basic Language. And I've written this up in Resurrection, you may have seen it, and that's what that looks like. That's proper assembly language. That's possibly the most obscure piece of assembly language I've ever seen. But look at it very carefully. We've got this thing here that says star equals A51 plus brackets A92 M1 equals brackets. That doesn't actually make sense. And the reason that doesn't make sense, and there's a lesson to be learned here, is that that is not an equal sign, that is a minus sign. Because line printers weren't all that accurate. And that took me about 3 weeks to get past that. I really didn't understand what was going on. So that's the second strand. The third strand, the third piece of software, which has been alluded to, compiler. That also in itself comes in 3 parts. You'll remember that Julius Caesar said that the world was divided into 3 parts. You won't remember this.
We have to do it for all that.
So here we are, 3 parts. See if I can. Oh, that's the equal sign. You can see it rather better there. The equal sign that never was. There are several of them there. The line printer's not necessarily particularly accurate for you. Right, so there's what we started off with in compiler. The compiler came on paper. It came as a printout, not of line printers, but from paper tape devices. This particular part came as 30 octal pages. There are 3 parts. 30 pages of octal, looking like that. Very faint, on yellowing paper. And whereas the first 2 parts, I was wrestling with all this on my own, David's earlier paper said you really need 2 people working on it, and you need to do 2 copies and compare them. And that was really very, very good advice. I've got somebody else involved in this, a gentleman by the name of Ian Cohen. He was my tutor at university many years ago. But before that, he was actually one of the authors of Compiler. And he had a copy, a source copy that he'd made on the day he left the University of Manchester in 1963. And he had kept it for all these years. And the university also kept an identical copy, the carbon copy. We know it's a carbon copy because where he's actually scissored through the paper is exactly the same in both cases, even to the point of actually going through the text in some places. This is actually very challenging. It's virtually a featureless piece of code. This is actually the output from an assembler which was written on Mercury before Atlas was running. We figured that somehow this must have been the case, and we later found some documentation that proved that it was indeed what happened. Before Atlas was running, they wrote an assembler for Atlas, and this was the output of it. One of the things which is quite challenging here is that the 6s look rather like zeros in some cases. They are really quite similar. Ian and I both had a copy of this, because I've got a copy from the university as well. And we both OCR'd them. We both OCR'd them with the same piece of software. That might have been a trace. And then he sent me his copy and I compared them, and when there was a clash, I looked at the original, worked out what it should have been. And say 30 foolscap pages of that. Foolscap is also a problem because the average scanner doesn't support foolscap, so you have to do a cut and shut job on it. It took us some weeks to actually get through that, to get through it accurately, by which time we OCR'd it 3 times, not just 2, and compared them again. Now, that's just the first part. That's 30 pages. What we had managed to get into the machine, and I had to write a compiler to compile that up to, what we managed to get into the machine was actually a compiler for this. And this is almost proper assembly language. This is something called intermediate code. This is not the final assembler, but something like it. And we had 110 foolscap pages of that, so you can imagine that took us some considerable time. Ian and I both worked on it together, and we did 10 pages at a time. We scanned them all, we cut and shut them all, we OCR'd them all, we compared them, and then we compared them again. That you can imagine it took us some time. And what this is a compiler for the next section, which looks like that. By this time we moved off the 5-hole tape, which the first section was in, and we're now in 7-hole paper tape, which is a lot more readable. Readable, except that OCR doesn't like Greek characters very much. Alpha and beta were employed to provide a compiler, as you can see there, and that did require quite a lot of hand intervention, as you can imagine. And again, there's 70 pages of foolscap looking like that. But finally, we got something which would load, didn't run, at which point a third member of the team popped up, Bill Purvis. Bill Purvis doesn't like Windows, he likes Unix, and he hasn't got a C# compiler, he has a Java compiler, so he wrote the relevant bits, he copied the relevant bits of the emulator. We had adapted them for use under Linux and translated them into Java, and he now also has an emulator. Bill and I spent some weeks making sure that the emulators produced the same results when faced with the same program. Again, you can imagine that took some time as well. But happily, Bill, along the way, suggested to me a number of ways in which we could improve the diagnostics of the programs, like producing trace files, which have been very successful, largely so that we can actually compare our 2 trace files and see if they're the same. So eventually, we managed to debug this lot. We managed to get it to the point where something could happen. So, we do have encountered a number of problems. One is that this source code, as I said, was printed out in 1963. The emulator implements a version of the operating system which was around 1965, and there is a mismatch. What worked in 1963 against the operating system doesn't work in the same way in the 1965 operating system. So we had to make some adjustments. And I had to recode a whole section which involved the saving of the compiler and registering it with the operating system. That wasn't too hard, that only took a couple of weeks. So it's a little partial recode. And when we finally got that done, we wrote a little test program just to prove that it works. And what the compiler does is it sets up a syntax definition and it associates that with a routine which you're supposed to execute. This is a very trivial program by the compiler. It has 2 formats. One is called start, and the other one is called stop, so that you will try to recognise the phrase start and take the corresponding action. You'll try and recognise the phrase stop and take the corresponding action, one of which involves a stop instruction 1117. That is our test data. The start, stop, and end of message for reasons I haven't yet discovered. And that is the output. That's all it does. It isn't a proper compiler, but its relationship to the operating system is the same as a compiler would be. So we're quite satisfied with that. You will notice, of course, that Atlas never had to deal with the millennium question. We're done. Thank you.
George, thank you, Dick. Now, since talking to Dick and Bill, I've rather got the impression that the I've rather got the impression that the KDF9 implementation of Atlas Autocode is in fact something to do with the compiler, so I'm looking forward to getting back to that. That was really a screen I made in case Dick couldn't show up. So, having talked about strategy and sort of what I'm trying to do, which is to get these 3 R's, in particular the relevance. So I think if we can make it relevant, we can make the museums want to keep it. If we can't, then they won't. So I'd like to now look at Leo 3, which I'm working on now, as a case study. The documentation survives as loose leaf printing. It's got some funny page sizes. And the veterans survive as OAPs, which is very useful. So, step 1 is to photograph the printer listings, and there. There we are. These things are, shall we say, they weren't a lot better than the ones that Dick was talking about. And if you zoom in, you can see that we did have quite a lot of listings like this, which you can see they've been kept, but not what you'd call cherished. But John Dames found a large sheet of glass, which he then lays over the printer listing, and you can get photos like that. And I reckon, as a way of getting a digital copy of a line printer listing, that's about as good as you're going to get. And he's just got a large sheet of glass, laid it on the carpet, and he just goes along with his camera. And he's taken about 2,000 photographs. So that's been a great advantage. So we scan the manuals, and there, page of manual. That is a scan from a genuine Leo manual. And this is one of the nasty pages. And so whenever it wouldn't fit on the page, the people who wrote it decided that they would do something like that. The only snag with that page is there are 2 errors on it. But so we OCR them, plain text, fixed width, proofread and edit. We convert it to HTML. We decide to use UTF-8 to get special characters. And they can be read by any browser, delivered on the web, and they're searchable by Google as a result. And if we look, this is our web page for the manuals. You want that a bit bigger. And as well as scanning it, then we put hot links in, so there's the contents, and you can go to section 4, and that is the page which we have there now processed as an online web document. And if you actually look at the HTML, you'll see that it's actually deliberately very simple. If you take the HTML tags out, you can read it, even with them in. You can. So the idea of this is that even if versions of HTML change, it's such like, oh, that goes down to the end, which I haven't really intended, but you can see that that doesn't hide the information. If you just sort of stick it into Word for Windows and save as HTML, you get a file that's 5 times as big and quite incomprehensible. So we've got that working, executable, incredible emulation and comprehensible emulation, and I think we're going to need different offerings for different audiences. But executable software needs perfect source, and though our photos we think were not feasible for OCR, if you look at them, it's a barrel printer and the alignment's not good for a start. And everything that we've got is written in this language called Intercode, even the Intercode translator. And so we copied out by volunteers, and we used a lowercase 10 for a tenpence, and the 11pence was a lowercase e. Dick's problems with 6 and 0 are nothing compared to the problems with tenpence and 0. So the printer listing is actually very different from the source text. And I didn't know this until quite late in the project. And if we... This, would you believe, is actually Intercode source text. As you can see, it's highly mnemonic and extremely readable, like not. And if you translate it, then it runs our product, and you can then see it on the line printer, and that's what the line printer produces, which is actually a lot different. And we started from that and copy-typed it in that form, rather than trying to get somebody to convert it into source text as they went. And I think that proved to be a good decision. So, it's pretty well all numbers, no mnemonics, references and numbers, no hardware address translation, fancy contortions and relocation. The listing is in columns but read in lines. But we copy-typed it into a spreadsheet and then saved it as a CSV file, and then I wrote software to process the CSV file. See, I'm a Leo 3 virgin. The attraction of going to Leo 3 when it came was, because I've never met a Leo 3 ever, it allowed me to find out what it might be like a generation in the future trying to get your head round something that you'd never met before. So I did have a lot of surprises as a result. And of course, because we started in virgin territory, I need an emulator for the machine code, which is known as computer code. Interesting that the documentation is using quite a lot of jargon differently from current usage. Peter Byford of the Leo Society wrote a page in our Computer Heritage website, and I actually started with that and wrote a program to read that, or a slightly modified version of that, and to then generate the actual emulator which is there. So this is the emulator for Leo machine code. I'm proud of the fact it starts with a page of comment, but it's not on comment, I grant you. Now here's the sort of thing you get to, and the emulator is very much written like this. Each of those cases is one instruction, and an emulator is a rather special sort of program. Is that big enough to see, or should I blow it up?
It's fine.
Blow it up. And so you get this large flat structure, which is actually quite easy to do. And here, I only implement instructions when I've encountered them in genuine preserved software, and I've not met any Leo floating point software, so they all say not implemented. So if you're trying to obey a floating point instruction, it says not implemented. The whole thing starts out with everything not implemented. So the first instruction fails, but you then go and implement it, and it takes a few runs, and you get about 20 instructions, and suddenly you jump to 200 instructions, and now we do rather more than that. So, but Leo's this commercial order code, and let me plough down. There we are. I'm afraid some of the instructions look like this, where the mountains of the stuff. Dealing with Leo's special character instructions, and whether they were a good idea or not, I'm not at all convinced. So, back to this virginity also, of course, means that this language intercode has to be translated into computer code, and it was written in intercode. So, I wrote something to process the copy typing, even though it wasn't genuine source text. And I started with a summary in the manual, and that again used a giant switch statement with the not implemented technique. And eventually, it produced a rather special program. This was what it produced. And down the left-hand side is a binary program which will load into the emulator, and the emulator ignores all the rest. And that really is the structure that I produced. And until we got this thing actually working, we used this, and eventually we got this to the point where it works, so it then will translate itself. And all these are references meant to different, and so they're actually turned into hot links, so that when you click them, it takes you to the routine that they refer to. And so it's actually much easier to follow one of these listings than a real one on printer paper. So we eventually had to convert that into a paper tape that looked like input. We translated it with that thing, produced a tape image. The format of the tape turned out to be imperfectly documented. Had to write a loader to convert from the magnetic tape to stuff that would go into our emulator, and it all works. It could be a challenge. When I was a young lad, loss of virginity was a challenge, but it doesn't seem to be nowadays. This commercial order code still surprises me. It's signed and modulus in the main store, which leads to the concept of the ambiguous zero, and there's half a page of manual telling you what to do about it. I really think it's a bad idea, especially as it complements in accumulators. It's got variable radix, Negative numbers are extremely messy. But I understand this machine a lot better now. And this programming language, I think, is something you would hate actually to use, despite the fact that the Leo veterans think it's are quite enthusiastic about it. It has clever tricks in it though, which I think are nice to preserve, but its automatic double buffered I/O is concealed from the programmer and manifests itself as some annoying arbitrary restrictions, and that variable radix leads to frequent confusion on which radix to use. So where next? Well, where have we got to? Well, this is, sorry, wrong one. Down here, we've got an example, just getting the right directory, and then now this is the program, an intercode program that configures the master routine for a particular machine. We've got slight version problems like Dick had, and it seems to complain about the tape format, and so it says alarm for the operator, to which the answer to that is 4. If you read the manual, it tells you that. Yeah? And now it's done it. It says alarm 6 for operator. Now it turns out that alarm number 6 for operator means it's been successful. So it's and we can say option 3 to generate an actual tape. And now, and this is where we finally go wrong, because it deallocates the tape, shuts it down, and it's waiting for the operator to do something, and we haven't quite found how to do it because none of our volunteers has actually done this job. So they're all the same. Right, we've got one who was an operator, but this is generating the master routine, which was done in the factory. And so it actually ends up stuck in a loop, looping around, waiting for a device to become ready. But look, we've made a lot of instructions, folks. We can, and all that is actually run on this laptop. Wrong one. So we've got more program listings with more text on the web explaining this weird system, because trying to explain 1960s for today's audience. But let's talk about the lessons. Retention, by that I mean preservation, just keeping stuff, not losing it, such as happened to Leeds University stuff. But without relevance, I think institutions will not keep it. So, this relevance is so important. And of course, without the rescue, there'll be nothing to keep. So all the stuff Dick talked about with dredging around, what I've called software archaeology, dredging around all listings and things. If we don't do it now, while there are people around who understand it, then I think the stuff will all get lost. Because we've got no faith in long-lived media. I think you've got to be accessible via the web. And you must not forget the documentation. We've got to get that in electronic form as well as the software. And what I said earlier, I'm trying to recreate the original experience but without the drudgery. So I'm not going to bother with the overnight turnaround. And address multiple audiences, like the casual visitor, today's computer professional, and of course the serious student of IT history. And rescue, well, the techniques we've used, scans, OCR, copy typing. I think John Daines' photographs behind a sheet of glass were excellent. And then a criterion that we evolved in a much earlier project back in the 90s. Try and preserve data in such a way that you can recreate the significant properties of the original. At least if, in principle, if you have the relevant hardware. But keep the raw data, I think, because better OCR will appear. And don't forget the documentation. And I think We need to achieve emulation while the veterans are alive, because the documentation has errors in. You can't actually do it without that. You see, it's not perfect. There were 2 errors that I found in the magtape format, and I found these errors because I'd actually got a magnetic tape, or a simulated magnetic tape, written by the real software, albeit running under emulation. And we got a wrong address in something, and the documented rules get broken. It says you should always have character strings, should be a multiple of 5, but in this translator they're not. And the worst thing was subtract with a non-binary radix, so the decimal radix, but it had digits in it that were bigger than 9. Right? And the manual took, you know, it's only by having real software and trying it. In the event, when I do a subtract, I do both a binary subtract and a character one, and if there are things out, if there are digits out of the range, then I just give the binary answer instead. Because usually there were equality tests between character strings when they didn't really care about the radix at all. So, that's me, and let's be honest, this, without doubt, is a work in progress. Thank you.
David, thank you for that, and thanks also to Delwyn and to Dick. Right, questions? Oh, okay, wait a minute. That's a familiar face, Brian.
Can I add something? From David's told us about the KDF9 and the Whetstone compiler. Well, from the KDF9, really the only really significant bit of software is the Whetstone compiler and interpreter. And that was preserved by a Michael Poole. For reasons I'm not entirely sure why, but he did preserve it. And I only wish...
It was only a printout he preserved.
Yeah, just a printout, yeah. But a magnetic tape from KDF9 would have probably been worse after that many years. So there were a lot of other things that I should have kept and I didn't. And so keeping things is really a problem, and full marks are Michael to preserve in Whetstone, because it's marvellous to see it working again. I made lots of changes to it. Of course, that isn't in Michael Poole's copy, so what we've really got is the real version of it as it came from English Electric in 1964, I think.
2 questions, David, if I may. Firstly, you made a lot of references to long-term preservation of information to data. Are you aware that the British Library did quite a lot of work in the light of the Doomsday Project to try and develop a manufacturer-free format for data, because they just didn't believe in the current physical media available at the time?
I was involved in working with something called the Chameleon Project, which was using the BBC's Doomsday data as a test case to demonstrate that emulation could be used as a way of preserving information that was in a format tightly bound to an architecture. And in fact, Paul Wheatley and I were colleagues. And so, yeah, Paul's left the British Library now, but the British Library was actually part of that project, and it's actually through that project that the British Library stuff was actually gestated.
Thank you. The other thing, a very slightly naive question. You made a lot of references to concepts like intercode. And I can imagine somebody 50 years in the future scratching their heads and thinking, what the hell's intercode and what's its function? Is there anywhere, or is there an idea of writing down information about concepts?
It's on the website.
Right, thank you.
If you click that, you can get to that, but that's the sort of working place. And that's the web server that ran the Whetstone Algol example. It's actually a small ancient laptop sitting in the corner of my office. It's so old it doesn't have a fan. It only takes about 30 watts. and it just sits there as a web server running FreeBSD Unix and the web server. But yes, and it's all, the web server is all Java and Java servlets.
Questions?
Dave, you deliberately excluded drudgery, and I can understand why you did that.
It's good what, sorry?
Drudgery from your preservation, and I can see why you'd want to do that, particularly in the context of reconstituting software. I've been playing similar games and recovering the source of the Elliott 903 Algol compiler, and on my laptop my emulator runs 100 times faster than 903. I can build it in about 3 minutes. If I turn on the feature that tries to calculate the real elapsed time and the time it takes to read paper tape, it says, oh, it's going to take you 11 hours. And I contacted Frogger, he said, yes, and you haven't emulated stepping on the paper tape, the 2 or 3 minutes it actually takes about a week. And I think not to at all criticise what you're doing, I think it's spot on. There is also indeed, I think, to communicate what computing was like physically in the 60s. Now in museums we can do that to some extent with the surviving machines. I don't think any TMOC visitor would be patient enough to see me standing there building the Algol system. Video can help a lot. Just displaying some of these things in renditions of what the screens looked like in those days, or the printed form, and the barely readable ink on teleprints, I think is also very important. And so I think that's another strand that has to be added to the story.
Okay, do you recall my remark about an emulated teletype? I found emulated teletypes where what they do is they produce an image of what the paper tape would look like. Yeah? But that's not the emulation I'm after. I'm after the emulation of the physical experience of pressing the keys and watching the thing go across the screen and the paper racking up.
But hearing it. Yes. All the noise.
That's right. But I think that you need a mute button, otherwise you could become very unpopular.
Again.
So I thought you would.
Sorry, I'm going to put in me Fortin's words from the back here. I mean, one of the things, talking about the physical experience, was just how hard you had to hit those bloody keys on a teletype to get it to work. You need some resistance.
By typing on it.
Yeah.
Any more questions? Yeah, yes.
Yeah, well, you've sort of talked about shown these things, but how many videos have you produced? Because it seems to me to be essential to do that now, as you say, while the real equipment still exists. You know, you need to produce.
Well, the real Leo 3s are quite rare.
Well, no, but you were talking a moment ago about the 905. You know, have you got a video of somebody winding up a 905 paper tape? Have you got a video of somebody loading a paper tape into a 905 and running it?
Me personally, no. I did have a really nice video of an IBM 7090, which I copied from a BBC television programme, but I couldn't get copyright clearance for it. And I took advice from our chairman, who's a legal expert, as to whether I could use it without copyright clearance, and she said no. So.
And a video of somebody loading an EDS 80 disc onto an EDS onto a spindle.
I mean, I think it's a great idea to do all that, but I'm quite busy getting the software to work.
Would you like to say something about the? I was asking a question about emulating the discs, and you were saying that the discs are not real discs; they're entirely emulated.
Do you want to take that, Mike?
Does that mean you have to emulate, but you have to use an interface?
Yes, so what we did is we decided to emulate the disks at the disk control level, so where the cables would normally run between the physical drive and the disk controller. I emulated that interface. We actually knew that interface quite well because I'd already done the reverse in order to recover data off EDS80s in the first place. Although when it came to actually doing the emulator, and this is obviously another valuable lesson about documentation, we discovered that actually the real drives behave a bit differently than the specification and more surprisingly, the ICL disk controller relies on that in order to work. And unfortunately, the one copy of the EDS80 manual that we have, and by the way, the ICL EDS80s are not the same as the standard CDC drive model upon which it's based, so you can't just get the schematics off BitSavers, it's an ICL version. And if you like, the critical page of schematics is missing from the manual. So we had to do this by experimentation on a real drive once I realised I had a problem. It took quite a few weeks to sort out what was going on. And it was basically a timing issue, and the timings that are given in the specification of how the interface works are complete nonsense. It doesn't work like that at all, and you would only discover that by actually doing it.
So you read the stuff off the drive with an emulator to read what it was doing?
Yes, originally we did, yeah. And more recently I put the drive up again in order just to issue a few commands to it to find out how the timing really behaves. And as I say, discovered it was actually totally different to how the manual says it should work. And of course, once you discover this, it's easy to change your hardware, and it's controlled by firmware anyway, to change that to match what the real drive does. And having done that, we were able to get quite rapidly from reading one sector to just working basically. The other thing I should have mentioned probably is that the whole of the emulated storage is based on a micro SD card, and that holds 16 gigabytes, and that's not even the biggest one you can get. that emulates that entire room full of disk drives that I showed in there's another couple of rooms full as well.
Don't forget the whole thing's running on a Raspberry Pi anyway.
Especially on a Raspberry Pi.
Well, not wanting to tread on Rachel's toes, can I pick up the copyright point? Because this one was bounced to me by people in the National Museum. When I first got involved, I was still with Microsoft, and their question was running various Microsoft operating systems are out of date on disks that didn't belong to the machines on which they wanted to run it. I went and spoke to our corporate lawyers, and they really want to have that question asked. And the answer came down really quite simply. Most of the corporate lawyers are busy writing deals that earn revenue. A few are busy chasing the people who are trying to steal revenue from Microsoft, and there's no one available to do work that neither brings in money nor loses money. And so, provided you're not doing something which has a commercial implication, actually big companies can't be bothered. And we had that conversation, the head of PR happened to be joining it towards the end, and she said, besides, we wouldn't want the bad publicity of suing a museum for doing something worthwhile. So it's easy to say when the lawyer is absent, but I think concepts of fair use allow you to be a little bit cavalier with these things.
I felt I'd got a slightly harsh opinion, but bearing in mind, I expected it to be here.
Yes.
I wasn't going to go against advice, Dick.
Well, I can follow that up. We do take a somewhat cavalier approach to copyright CCS, both on the website and indeed in Resurrection, which is one of the reasons it's not actually integrated into the British Computer Society system. I worked for a while for General Electric, not GEC, but General Electric, and we were warned that we had to be very, very careful about this sort of thing. There were people who were quite ready to try it on with a company which had a lot of money, and GE has a great deal of money. But the corollary of that is that there are organisations with very little money, like CCS, like National Museum, that nobody in their right mind would try it on with them because it simply isn't worth it.
Exactly.
On the copyright issue, I was really quite surprised. I'm collecting material, which basically is from books, and the only way I can myself make sure that I'm dealing with these books correctly is to photocopy a little bit. So the question was, how do I preserve all this information? And I was delighted to find out that the V&A National Art Library were quite happy to take a copy of a DVD which contained a vast amount of material copied from copyright material, just because it's my working copies. It's not for publication, but it is, you know, you can have material like that quite happily stored under, of course, it's controlled, of course, but it's available. See what I mean? Personal copies of things can be made, and even the library, even the National Art Library, will take it.
Any more? Or is that have we drawn to a close? I think we've drawn to a close. Right, David, thank you for what promised to be and has turned out to be a fascinating afternoon. Thanks to Delwyn and Dick as well for their input. The next meeting is on December the... I've suddenly realised I didn't know the date. I can tell you it is the Christmas film show. Kevin and I are busy bringing various bits and pieces together, and my learned assistant here is... Sorry, December the 18th is the next meeting, and January the 11th is the first meeting after Christmas. That will be John Harper talking about 2903, and that promises to be an interesting afternoon. We've not covered that machine before, and yet it played a very important role at the time in ICL and computing, in the computer industry. So, can I thank you for coming today, and look forward to seeing you in the December meeting. Thanks.